These are your Algebra 1 notes, 4.7, Solving Systems by Elimination, Day 2. So we learned how to solve a system yesterday by using the elimination method. And when we look at this call-out box right here at the top, it alludes to something that we talked about yesterday in yesterday's lesson, that sometimes in order to get a variable to eliminate, you might have to multiply one of the equations. And sometimes you might have to multiply both equations in order to get two opposites that will eliminate. So you'll see this as we do these examples. So let's look at the first example. We have 3x minus 2y equals 19 and 5x plus 4y equals 17. Now, if we were to combine these equations, nothing would eliminate. We would end up with 8x plus 2y equals 36. Well, that's not going to help. We want one of the variables to be eliminated. So you have to look over the equations and ask yourself, what could I do to make this eliminate? And we see we have a minus 2y here and a plus 2y here. Well, how could I get those to be opposites? How about we take the first equation and multiply it times 2? So I'm going to distribute the 2 to all three parts of the equation. Remember, anything you multiply on the left, you've got to multiply on the right to keep the equation equal. So we have 6x minus 4y equals 38. And now the other equation we're going to bring over just as it is. And so we have 6x plus 5x equals 11x, minus 4y plus 4y, opposites, they're going to cancel out, and then 38 plus 17 equals 55. So we divide by 11, and x equals 5. Now, what do we do to get y? Take the 5, x equals 5, and substitute it back into one of the equations. So I'm just going to use the first equation. 3 times 5 minus 2y equals 19. Here, I'll draw a little line like this so we can see it. And so we have 15 minus 2y equals 19. So let's subtract 15 on both sides. So now we have negative 2y equals 4. I'll bring that over here. And when we divide by negative 2, we get y equals negative 2. So there's our solution. Let's always write it as a coordinate pair, 5 comma negative 2. And there you go. Now, you want to check your work? Plug the 5 back in for x, plug the negative 2 back in for y, and make sure it comes out right, which it will. Okay, let's look at example 2. Now, let's look this equation over and ask, what could we possibly do to make a variable eliminate? Well, there's a couple of choices. We could take this bottom equation and multiply it by negative 2, and if I did that, I would end up with negative 2x, and the x's would eliminate. Well, by the same token, I could take the top equation and I could multiply it by negative 2, and then you would end up with negative 2y right here, and the y's would eliminate. Either way you do it, you're going to get the same result either way. So how about we multiply the bottom one by negative 2? I don't know if that's the best choice or not, but let's try it. So the top one stays as it is, 2x plus y equals 4. And now when I multiply the bottom one by negative 2x, we get negative 2x minus 4y equals negative 28. So these have eliminated, and now I have plus 1y minus 4y. Remember, when your signs are different, subtract and keep the sign of the bigger number. So that's going to be minus 3y. 4 minus 1 is 3. So we have minus 3y equals, and here we have it again, a positive 4 minus 28. Subtract and keep the sign of the bigger number. So this will be minus 24. So we're going to divide each side by negative 3. And so y, these cancel out. A negative divided by a negative is a positive, so y equals positive 8. So now we can go ahead and plug 8 back into one of our original equations. So I'm just going to use the second equation. X plus 2 times 8 equals 14. It doesn't matter which equation you use, you're going to get the same answer either way. X plus 16 equals 14. Subtract 16, and x equals negative 2. So our solution is negative 2 comma 8. Now just in case you didn't believe me, let's try that with the other equation. I'm going to take the 8 and I'm going to put it into the first equation this time. So 2x plus 8 equals 4. So I'm going to subtract 8 on both sides. Cancel out. 2x equals negative 4. Divide by 2. And x equals negative 2. So the first time I put it into this equation and got negative 2. The second time I put it into this equation and got negative 2. It works out either way. You know why? Because math is cool. Okay, let's go on to number 3. So let's look this problem over, and what can we do to eliminate a variable on this one? Well, I think the easiest thing to do would be to take, we have a 3y up here and just a 1y here. So if we took this bottom equation and multiplied it times negative 3, then I'll end up with negative 3y, and we'll be able to eliminate the y's. So let's try it. Why don't you try it without me? Go ahead and do the multiplication and see if you can get the right answer. Hit pause, and you can check your work at the end. So I hope you ended up with x equals 2, because 7x minus 12x, negative 5x, negative 1 minus 9, and the signs are the same, add them up and keep the sign, negative 10, and then a negative divided by a negative is a positive. So now let's take this 2 and plug it back into one of the original equations. So I'm going to use this second equation. So 4 times 2 plus y equals 3. 8 plus y equals 3. Subtract 8, and y equals negative 5. And there's our solution, 2 comma negative 5. Always write it as a coordinate pair. Okay, take a look at number 4, and what do you think you can do on that one? Well, let's see here. We have a plus 5y, we have a minus 15y here. What if we just take the top equation and multiply it by 3? Then I'll have positive 15y on the top. So we get negative 36x. Remember, I'm going to multiply everything by 3, plus 15y equals negative 15. And then 9x minus 15y equals 6. So now let's combine the two equations. Negative 36 plus 9. If you don't know how to do that, we're going to subtract and keep the sign the bigger number. Use your calculator if you can't do the addition and subtraction yourself. That's negative 27x equals negative 9, because we've got minus 15 plus 6. So now we're going to divide each side by negative 27, and oh, we're going to end up with the dreaded F word here. We're going to end up with a fraction, and so we've got x equals, and we have a negative divided by a negative is a positive, and then we want to reduce this fraction, and we can reduce it by dividing by 9 over 9, and you get positive 1/3. Now, if you're having trouble with that, put in your calculator negative 9 divided by negative 27, and then just use your fraction button to figure it out as a fraction. Okay? You would end up with 0.333 like that, but you don't want to use a decimal in these problems. You always want to use the fraction, because if you use the decimal, it's not going to come out correctly. So let's go ahead and take this 1/3 and plug it back into one of our original equations. So I'm going to do it on this second equation. So we have 9 times 1/3 minus 15y equals 6. And 9 times 1/3, remember, multiplying by 1/3 is the same as dividing by 3. So we have 3 minus 15y equals 6. So we're going to subtract 3, and we get negative 15y equals 3. And now we divide by negative 15, and we're going to end up with the dreaded F word again. A positive divided by a negative is going to be a negative, and 3 over 15 would reduce to 1/5. So negative 1/5. So our solution is 1/3, comma, negative 1/5. And there you go. There's your solution. Okay, so now we're on example 5, and it's a little more tricky than the ones we've done so far, because on this one, if we look it over and try and figure out what we can eliminate, we're going to have to multiply both equations. There's no getting around it, because we need to have one of the equations be positive, the other one has to be negative, and then they both have to have the same number. So you got a 4 and a 3, you got a 3 and a 2. They don't have common denominators, so we are going to have to think about this, and I think what I'm going to do is take the top equation and multiply it times 2, and I'm going to take the bottom equation, I'm going to multiply it times negative 3. Now let's see what that would do for us. It's going to help me with this term right here, because negative 3 times positive 2 is going to be negative 6, and negative 3 times negative 2 is going to give me positive 6 right there. So it's going to help me eliminate the y's. So let's go ahead and try it. We're going to first multiply everything by 2 on the top equation. So we have 8x minus 6y equals 24. And now we're going to do negative 3, and times 3x is negative 9x plus 6y equals negative 12. Positive times a negative is a negative. Now, 8x minus 9x is going to leave us with a negative 1x. These cancel out, and 12 minus 24 is 12. Now, we don't want to have a negative sign hanging out there on the end, and we know that we can do a shortcut. We can divide each side by negative 1, but that shortcut is just to change all the signs. And that means x is negative 12. Okay, well, now that I know x is negative 12, let's plug it back into one of our equations. So I'm going to put it in the second equation. So 3 times negative 12 minus 2y equals 4. So we get negative 36 minus 2y equals 4. So now we have to add 36 to both sides. So I have negative 2y equals 40. And we divide each side by negative 2, and we get y equals negative 20. So there's our solution, negative 12, comma, negative 20. So are you catching on to what we need to do on these equations? It's like a little puzzle you have to figure out. And our goal is to always figure out what do we need to do to eliminate a variable. Okay, so let's look at number 6. We've got another little puzzle here. We want to figure out what we can do to make a variable get eliminated. Now, as I've said before, there's lots of different ways that you can do this. There's no just one right way. On this particular set of equations, like these are both negatives right here, so I could maybe multiply the top one by negative 5 and the bottom one by positive 8, and we would end up with negative 40 down here, and we would end up with positive 40 up top. So that's one way you could do it. And since these are both positive, 3x and 4x, I could multiply this one by negative 4 and this one by positive 3. Then I end up with negative 12x here and positive 12x there. So there's several different ways you could do it. So you just have to pick the one you want to do. I think what I'm going to do is multiply this top equation by 4 and this bottom equation by negative 3. That's what I'm going to do. So we're going to distribute, and we get 12x minus 32y equals 52. On the bottom side, we have negative 12x plus 15y equals negative 18. Now, let's combine the two equations. These cancel out, and now we have negative 17y equals positive 34. Divide by negative 17, and we get y equals negative 2. Now that I know that y equals negative 2, pop that puppy back into one of these equations. I'm going to use this one. So 4 times x minus 5 times negative 2 equals 6. So we have 4x plus 10 equals 6. I'm going to subtract 10 from both sides. So we get 4x equals negative 4. Divide by 4, and x equals negative 1. And there we go. Negative 1 comma negative 2 is the solution. And we're done with that one. So let's move to the back. Okay, why don't you try number 7 without my help? See if you can do it. I want you to hit pause, look it over, see if you can make a plan for eliminating one of the variables. And then you can check your solution at the end. Okay, so here's the solution, 5 comma negative 2. If that's what you got, then you can just fast forward through what I'm going to show right now. And if you did not get 5 negative 2, then watch me work the problem. So what I'm going to do, what I decided was to multiply the top equation by negative 5 and the bottom equation by 7. And by doing that, it will help me eliminate these y's. So watch, we get negative 20x minus 35y equals negative 30 on top. And then I get 42x plus 35y equals 140 on the bottom. These eliminate, and so we're left with 22x equals 110. Divide by 22, and x equals 5. Once I know that x equals 5, I'm going to plug that back in, and I used the top equation for this one. So I did 4 times 5 plus 7y equals 6. So 20 plus 7y equals 6, and I subtract 20. And I get 7y equals negative 14. And divide by 7. And y equals negative 2. I'm going to write that just a little better so you can read it. 7y equals negative 14. Divide by 7. Y equals negative 2. So our solution is right here, 5 comma negative 2. Okay, so on the next question it says Carrie and Amy are shoulder partners. They both worked the same problem but got 2 different answers. Who's incorrect, and explain the error that they made. So I want you to look those over, see if you can figure out who made the mistake. Use your pause button and try it yourself. Okay, Carrie's the one that made the mistake. And let's see what happened. Basically, what they both decided to do was to just subtract the equations. And subtracting it would be the same as multiplying by -1. So you see this little negative sign they put out here in front of the equation. If you were to distribute that negative sign, or in other words, multiply by -1, the top equation would stay as it is, x plus y equals -3. But when we do the minus sign, we're going to end up with -3x. We're going to end up with minus y, and then we're going to end up with -3 again. And so x minus 3x, 1x minus 3x is -2x. These cancel out, but -3 minus 3 equals -6. Not 0 the way she has it here. See right here, she forgot to multiply that one by the -1. And you can see Amy ended up with -2x equals -6. And they're not really showing their work real well here. X plus y equals -3. And again, you're going to end up with negative sign. So -3 minus 3 is -6. So Amy got it right, and Carrie made the mistake. Okay, last question, number 9. The Lees spent $31 on movie tickets, 2 adults and 3 children. The Mashas spent $49 on movie tickets, 3 adults and 5 children. What are the prices for adult and child movie tickets? So let's go ahead and write let statements. Let's let x equal, remember, we can find what our let statements are by looking at what the question is asking for. So we're going to let x be the price of adults, and let y equal the price for children. Price of adults tickets, I guess, would probably be better. And then let's write 2 equations. So we have 2 adults times whatever the price is, plus 3 children times whatever the price is, equals 31. And then you get 3x plus 5y equals 49. So now we're going to have to figure out what can we do to solve this. And so let's see here. How about we multiply the top equation by 5 and the bottom equation by -3. What would that help me eliminate? It would help me eliminate the y's. So when I do that, we're going to distribute, and so we end up with 10x plus 15y equals what? Equals 155. And then when we multiply the bottom one by -3, we're going to get minus 9x minus 15y equals minus 147. And when I do that, these cancel out, and 10x minus 9x is 1x, so we get x equals 2. So the price, it appears, of an adult ticket is $2. And then we take that 2 and put it in and to one of the original equations. So let's see, I'm going to use the first one. 2 times 2 plus 3y equals 31. So we get 4 plus 3y equals 31. Subtract 4, and you get 3y equals 27. Divide by 3, and y equals 9. So I guess this movie theater doesn't like children very much because they make the cost of kids' tickets a lot higher than the cost of adult tickets. This is the theater where adults want to go for a date night because they don't want to spend that kind of money on their kids. There you go. $2 for adults, $9 for children. Okay, so there's your lesson on Elimination Day 2. I hope you're getting the hang of it. You're going to be having a quiz coming up and then a test real soon. So you got to keep practicing. So good luck on your homework. See ya.